Hello, pharmacy students. Of course, it's calculations time again with Dr. Dave. I'm going to be talking about percents in pharmaceutical calculations. This is perhaps one of the most important concepts for you to understand and realize. Is first, what is a percent when we see it? And what's important in pharmacy calculations is not just to see numbers, but to put meaning to the numbers. The meaning of the numbers is what we're going to really be discussing here. So first, let's just go with the basics about what is a percent. We might have all seen the percent sign. Most people may say, well, it's out of 100, or it's something that means in 100 or out of 100. That is the important thing to understand with the percent sign. When you see the percent sign, you know that it is something per 100, meaning that it's a ratio where the denominator is 100. What units you put on there is what we'll be discussing. So for example, if you see something that says 5%, how do you interpret that? Meaning, how do you say it in words? How do you write it out? Right? You can say it's 5, right, over 100. You can put it as a decimal, right? You can also say that this is 0.05. You can also say that there's 5 of something per every 100. Some people may also say parts, so you can say 5 parts per 100 parts. And you may also use what we've talked about before. You can say 5 to 100, right? You can reduce that, but you can say 5 to 100, meaning 5 parts every 100 parts. We're going to put a little bit more meaning on that with units in a second. But let's utilize what a percent is. From now on, every single time you see a percent, you must think out of 100. You must think of a ratio with a number that has 100 on the bottom and the number on top being what that percent number is. So let me give you an example. In a study, you've got 1,507 participants. 2% of the subjects experienced nausea and vomiting. This is nausea and vomiting abbreviated. So what is the number of participants that experience nausea and vomiting? So if you read a study and you have a patient who's getting a prescription or something similar, and you know that 2% of the patients got nausea and vomiting, what percent is that? I mean, how many people got it? Well, we take 2%. Anytime you see a percent, you're always going to put it over 100, right? This is 2 people experience nausea and vomiting out of 100 people total, right, in the study. So if 2 people out of 100 experience nausea, how many people, right, would that be if you had 1,507 people in the people total, right? Right? 2% means there's 2 people every single time you had 100. So every time you have 100 people in your study, 2% or 2 will get nausea and vomiting. So if you've got 1,507 people, that's about, this number is going to be 30.14. So this is approximately 30, right? So about 30 patients in a study of this drug, you will see experience nausea and vomiting if around 2% of the people do it. The math that I'm doing here, you could easily do your ratios that you say there's 2 people. So let me write this in a different color just to show a point here, because you will see me do calculations in a shorthand version, which is what happens. So most people will do this. 2 people experience nausea every time there's 100 people total, right? And it says how many people if you've got 1,507 total, right? And then people, like I said before, you would cross multiply and you saw fracs. Again, cross multiplying doesn't really exist. What you are doing here is you are multiplying this side of the equation by 1,507, which is what I'm doing here. I'm multiplying this by 1,507. Notice this is exactly what I have here. And this would eliminate this, and you'd be left with x. So I am just avoiding the cross multiplication step when I do it. All I'm doing is making sure that my units cancel out, and the unit that I'm looking for is on the denominator, as I discussed in that first video lecture for the math review. All right, so let's look at it from a different angle. This says that you've got 841 patients, and 65 of those patients experience vertigo or dizziness, is what that means. So if you had to describe what's the percentage of people that had vertigo, well, you can start with, you know that there's 65 patients, right? And 841 of those patients, right? 841 total. 65 of those people experience vertigo. You know that 65 people out of 840, in order to have a percent, you need to know what it is out of 100 people. So this is out of 100 total. So let's say instead of having 840, you just had 100. What would the percent be? And that's about 7.7288 roughly. So you're going to get roughly about 8%. If you round it up, about 8% of the people are going to experience vertigo or dizziness in that. All right, here's another example with when you're making products, or if you see products in the pharmacy that are dispensed. This is a gel. So if you have a gel, you've got a tube of that gel. So I'm going to draw a really bad picture of a tube. All right, here's a tube of a gel. Right. And this tube is 60 grams. That's how much it is. And inside of that 60 grams of gel, it's got inside of it 1.5 grams of drug. The question is, what's the percent concentration of drug in the gel? Again, you want to ultimately find out what is the percent, meaning how much in 100 grams. You know that there's 1.5 grams in 60. You want to find out how much there is in 100, meaning I've got 1.5 grams in 60 grams total. Right? This is 1.5 grams of drug. Right? How many grams of drug if I've got 100 grams total of this gel? Right? So the way I would do it, again, I would say, well, you've got 1.5 grams of the drug contained in 60 grams total. This does not mean 60 grams plus 1.5 grams. This means that in the 60 grams of that product, that final gel, you've got in that, contained in the 60 is 1.5 grams of drug. How much have you got? 100 total, right? And that's going to give me about 2.5%. That's what I'm looking for. So now we know that the drug in the gel is 2.5%. All right, this is the most important slide of this percentage thing to realize. You will utilize this throughout the rest of the course, so please pay attention to this. And if you need help, watch it again, read the book, or ask me. There are 3 types of percent concentrations that we typically will encounter in pharmacy. There's 3. This is it. If you learn these 3, you are almost learning everything you need to learn about percents. We mix 3 things. We mix powders with powders. We mix liquids with liquids. And we can mix powders with liquids. Or you can say liquids with powders, however you want to talk about it. There's 3 things. So that's why you see solids with solids. These are meaning powders with powders. You can mix solids with liquids, so powders with liquids, or we can actually mix liquids with liquids. Let's talk about each one of these. If you want to mix solids with solids, so when you're mixing solids with solids and somebody gives you a percent, so here's a percent, it means something in particular. It means the number of grams per 100 grams of the product. Let me say that again. Anytime you see a percent, it means the number of grams per 100 grams of the product, the mixture, when you're dealing with solid material. Let's do an example. it says a 5% weight in weight drug solution. This WW means weight in weight right here. Weight meaning the unit is going to be a weight unit, and the bottom number is also going to be a weight unit, and the weight unit is going to be grams. So every single time you see 5%, 6%, 2.2%, 72.8%, and it's talking about a mixture of powders, that means the number of grams of drug over 100 grams of the material. So if somebody says 5% of a drug powder mixture, that means that there is 5 grams of drug. Let me draw this out, what that means. If you're going to make it, what that means is that you've got 5 grams of drug. So this is my balance here. This is my balance. I got 5 grams of drug right in there. All right? Then I'm going to add to that 95 grams, right, of another material, of an inactive material. So this is 95 grams of something else. This is the inactive mixture. When I'm done, let me write that in red maybe. When I'm done, that's going to say 100 grams. This is what a 5% is. It's 5 plus 95. The total of this is going to be 100. That's a 5%. Weight in weight. The concept here to realize is that when you see a percent for solids and solids, it's it's weight per weight. Let's do another one with solids and liquids. When you see solids and liquids, you are going to be referred to as, instead of weight per volume, which is what we had here, it's going to be weight per volume, meaning some amount of drug as measured in weight in some amount of volume. It's always going to be grams over 100 mLs. That's what the percent is going to be. So let's take the exact same thing. If I tell you that you have a 5% drug solution in front of you, and it was made by mixing a powdered drug into the liquid, and I told you it was a 5%, that means that I put 5 grams of drug in 100 total mLs. How do you make something like that? In this case, what you would do is you would take the drug. So let's take our drug. We would put the same thing we did before. We would have 5 grams. This is a graduated cylinder. So we've got 5 grams of the drug sitting on the bottom. We are going to take water, and we are going to add water into this graduated cylinder. Keep adding water, keep adding water, keep adding water, or whatever our solvent is, until we get right to the 100 ml mark. This adding enough liquid until we get to 100 mLs is something we refer to as QS. QS. It's a Latin term. If you want to think about it in English, you can say quantity sufficient, meaning we added a quantity that was sufficient to get to the 100 ml mark. So how do you make a 5% drug solution? You add 5 grams of drug and you QS to 100 mLs is the terminology we would use. Let's look at the last one, which is liquids and liquids. Again, liquids and liquids, when we're talking about percents, is always going to be a volume by volume. So some amount of a drug solution added to some other ingredient or some other liquid. And the units are always going to be mLs per 100 mLs. That's the percent. So 5% volume in volume means that you've got 5 mLs of the drug solution in 100 mLs of the total. How does that look? Again, this would be, we would put 5 mLs this time instead of 5 grams. We would put 5 mLs, and we would QS. Let me draw that so that it's consistent here. We would put 5 mLs, right, of drug. Right. And then we would QS all the way up to that 100 ml mark with our solvent or solution. This is how we make a 5% volume in volume solution. Let me quickly recap for you. For the percentages, we're looking at 3 things. We're looking at, anytime you see a percentage, it's either going to be a weight in weight, a weight in volume, or a volume in volume. Sometimes it specifically says it. Sometimes you will see it advertised or shown with volume and volume, or it will be shown with weight and volume, or it will be shown with weight and weight. Sometimes it won't. When it's not, it's understood the way that it's done. If it's a powdered mixture and it says a 5% mixture of powders, you know it's weight and weight. Important to understand that the units are grams per 100 grams of the total material. If you're dealing with the volume on the denominator, you're dealing with out of 100 ml. So grams per 100 mLs for solids and liquids, and mLs per 100 mLs if you're dealing with liquid mixtures. All right. So again, that is percents and the understanding of what percent means when we're dealing with pharmaceuticals. That's it for this lesson on pharmacy calculations, the most important class because it's the only one that counts.